It's a pleasure to be with you all today, and I'm sorry that we couldn't be together in person. In sort of the irony of ironies, over the last 2 days of not traveling, I've contracted a cold from one of my kids. I'm hoping that this doesn't adversely affect my voice, but if I start to tail off, let me know and I can project a little bit more. Wanted to start out by saying thank you to the NARUC team, Carrie, Dominic, and Charles and Lisa for pulling this together on short notice. It's been a heroic effort. And I also wanted to thank those of you who've made it through to the end. I know there's been a lot of information. We've covered a really amazing amount of ground over the last 2 days. As Lisa mentioned, I'm going to be talking about grid modernization investment economics. And this builds on the presentation that Paul gave yesterday, and we'll build on Lisa's presentation. This is a chapter in the forthcoming Modern Distribution Grid Guidebook. Next slide, please.
Pardon the interruption, but Fritz, we did have 4 polls for you, and we did not get notes on which slides they belong to, so just...
Oh, let's do the polls at the very end.
Okay, perfect.
Okay. So I wanted to start out by stepping back and providing a little bit of context and motivation. Over the last several years since grid modernization has become a term of art, I think there's been a growing consensus on the vision of what we want the future distribution grid to be, what characteristics we want it to have. That is, it should be reliable, resilient, secure, information-rich, customer-centric, automated, flexible, affordable, and clean. But there's been a lot less consensus on the pathway to get there. And one of a major challenges has been the way in which utilities and regulators go about evaluating investments. Next slide, please. And so this is actually a really complex and challenging problem, and maybe in some ways surprisingly. I wanted to walk through 4 reasons why this is complex and challenging. The first reason is the whole versus the parts. In thinking about sort of planning for grid modernization, it's important to have this holistic vision and investment strategy. But at the same time, we're going to want to peel apart this package of grid modernization investments into individual parts for the purposes of evaluation, because different investments are likely going to have different metrics that we're going to want to apply to them. So reliability and resilience is a great example of this. So we want to plan for a grid that's both reliable and resilient. We don't want to sort of plan separately for a reliable grid and a resilient grid. But at the same time, the metrics that we're going to want to use to evaluate investments that contribute to reliability and resiliency are likely going to be different. And Joe Edo's presentation touched on this a little bit. And so how to kind of develop a framework that allows us to maintain this holistic vision and strategy, but at the same time being able to separate investments into individual categories for evaluation is a major challenge. The second challenge is resources versus the grid. So at least some grid modernization investments are going to support distributed energy resources. And so there's a temptation to want to use the same methods that we've historically used to evaluate distributed energy resources. So the traditional kind of cost test to evaluate grid modernization investments. But the problem is historically we haven't used that sort of benefit cost framework to assess distribution system investments. And so figuring out when we want to use benefit cost analysis for grid modernization investments and when we want to use some other method is also sort of emerging as a challenge. The third area is that some grid modernization investments have joint and interdependent benefits. Joint benefits meaning that a single investment will contribute to multiple objectives and have multiple benefits. The interdependent benefits meaning that a single benefit or single investment may not on itself produce that much in the way of benefits without other investments that complement it. So a great example of this is communications infrastructure. So the communications infrastructure on the distribution system will be be important for just about everything we do in the future distribution grid. It'll be important for the advanced metering, everything from the advanced metering to sort of the potential for doing security constrained economic dispatch on the distribution system. But the communication system on its own may not, won't do anything without having other investments that complement it. So we need the metering infrastructure, and we need the sort of software and control systems for dispatch to make it meaningful. And so how to evaluate these kinds of investments is also a major challenge. And then the fourth area is uncertainty. So we're sort of in the foothills of grid modernization right now. And there's a lot of uncertainty over technology costs, technology fit, whether technology makes sense for a particular utility, the technology maturity and potential obsolescence. So if we make this investment now, is it going to be obsolete in 2 years? And this uncertainty is also a major challenge for grid modernization. Next slide, please. And what we sought to do in the guidebook was to come up with a relatively general economic evaluation framework that could inform the way that regulators and utilities are thinking about how to deal with these challenges, recognizing that there's no textbook approach to doing this and that there's multiple reasonable ways to achieve the same kind of set of goals. Next slide, please. So the framework, the economic evaluation framework that we developed as part of the chapter in the guidebook has 3 stages: a planning stage, a deployment stage, and an evaluation stage. And let me state the obvious and note that what we're trying to do with this is tie together the economic evaluation framework and sort of a longer term strategic planning process. So I'm going to go through the steps in this framework relatively quickly, and then I'll come back and talk about some of them in more detail and use this to frame the rest of the presentation. So first step is developing and prioritizing objectives and setting spending limits. So this idea of setting objectives may sound relatively obvious and trivial, but this is really the cornerstone of both the economic evaluation framework, but also sort of a longer-term grid modernization planning process. I think the place where regulators and utilities want to avoid being is having utilities kind of show up with investments that they've either already made or are about to make and ask for cost recovery. And this puts regulators in a very difficult position of not having context and not knowing what the investments were meant to do. Second step is in coordinating processes, as I'll discuss a little bit more in a second. Grid modernization it touches on a number of different utility processes, and making sure that these are all pointing in the same direction is important. Third step is identifying investment needs, priorities, and timelines. So this is the explicit link with this long-term strategic planning process. And this is sort of the road mapping step. Next step is linking needs to objectives and developing performance metrics. So this is the what do we expect investments to do step. The next step is categorizing investments by evaluation drivers. And this is the, how are we going to evaluate different investments on an ex-ante basis step. And we'll talk a little bit more about this in a second. And next step is actually deploying investments. And then the final step is evaluating investments and adapting investment strategies. And this is something I'm going to harp on. You're going to get tired of me saying over the next 20 minutes or so. It's really, really important to build this learning and adaptation strategy into an evaluation framework. Next slide, please. So diving down into some of these in a little bit more detail, the first area I wanted to talk about is prioritizing objectives. So as Lisa just mentioned, I think in most cases what we're going to find when we kind of lay out all of the things that we want to do with grid modernization, we'll discover that when you sum up all of the costs of doing so, they're going to expend the amount of money, they're going to exceed the amount of money that we're willing to spend. And so the question for a lot of regulators and utilities is not just what do we want to do, it's what do we want to do first. And this is the sort of the idea behind prioritizing objectives. It's setting out what are the things that we want to do first. And different jurisdictions are going to take different approaches to this. So in some jurisdictions, for instance, customer choice might be the thing that we want to do first. And in that case, the investment priorities are going to be things like advanced metering infrastructure. In other jurisdictions, distributed energy resource integration is going to be the priority. The investment priorities are going to be things like the information control systems that enable us to get higher DER penetration. In some jurisdictions, reliability and resilience is going to be the #1 priority, and we're going to prioritize things like feeder upgrades, automation, outage management systems. But this sort of process of prioritizing and prioritizing different objectives will shape both the sort of the planning process and the way that jurisdictions go about economic evaluation, and for two reasons. One is it will help set what the investment and spending trajectory looks like over time, but it also inform approaches to cost allocation. So, for instance, in jurisdictions that feel that distributed energy resource integration is a priority, there's probably going to be more appetite for socializing some of the investment costs that are needed to make that happen. And we'll come back and talk about that in just a bit. Next slide, please. So the second area I wanted to talk about is coordinating processes. So grid modernization touches on just about everything that utilities do, from grid resilience planning to retail rate making to transmission planning to integrated resource planning and utility programs to interconnection processes to distribution capacity and resource planning, and then to grid modernization planning in itself. And it's important to maintain, and just echoing something that Lisa said, it's important to maintain some degree of harmonization across these different processes, both to make sure at sort of a minimum level that we're not making investments that run counter to one another, and that we're, even worse, that we're not making the same investments twice, but also to make sure that the inputs that we're using in these different planning processes are consistent. So, for instance, making sure that the cost assumptions used in interconnection processes are consistent with the cost assumptions that we're using in non-wire procurement. There are several different approaches to coordinating among these different processes. So some jurisdictions have used the grid modernization proceeding itself as the way to coordinate among these different processes, and use long-term plans and short-term implementation plans as a way to sort of coordinate. In other jurisdictions, for instance, in California, the general rate case has been the proceeding that integrates all of these different processes. Next slide, please. So the next area I wanted to talk about is targeting economic evaluation. And targeting here means that we're taking individual investments and mapping them to economic evaluation methods based on their drivers. So in the report, we identified four investment drivers. The first is joint and interdependent benefits, and we talked a little bit about this already. These are investments that have joint benefits and benefits that require other investments to sort of make them achieve their expected benefits. And these are core platform investments. And I'll revert in a minute or two and we'll give you a reminder of what core platform investments might entail. The second driver is standards compliance and policy mandates. Standards compliance meaning investments that are needed to comply with safety and reliability standards. And policy mandates, this was a little bit of a slippery concept, but could be things like investments that are needed to comply with safety and reliability standards to meet, for instance, a state DER policy. So these two categories of investment drivers map to a least cost best fit standard. Least cost best fit means that we're not necessarily going through the process of trying to quantify all of the benefits associated with an investment. We're identifying what functionality we need, and we're looking across different potential investments and saying which investments provide the best fit for this functionality at the lowest cost. The third category of drivers is net customer benefits, and these are investments from which customers receive net benefits in the form of bill savings. And these map to more of a traditional benefit cost analysis framework. So these could be part of for instance, a non-wires procurement process, utility IRP, or utility programs. And again, the thing to emphasize here is that these aren't necessarily, we're not necessarily talking about evaluating the resources per se. What we're evaluating is the grid investments. So, for instance, as part of non-wire procurement, we're asking, do the resources plus any incremental grid costs they might trigger provide a benefit cost ratio that would, relative to sort of a traditional capital solution, that would warrant their investment. And then the last category of driver is customer choice, and these are investments that customers make of their own accord. So this might include wires undergrounding for communities that petition the utility to do it. It could include customer investments that are triggered as in part of the interconnection process for instance, distributed PV. And these investments map to a self-supporting evaluation method. And self-supporting refers to the fact that because customers are willing to make the investment in these resources, we're assuming that they're cost effective. Next slide, please. So there's different levels of doing the categorization for economic evaluation. There's more of a detailed approach. This is an example of an illustration of a more detailed approach. So the four boxes on the left here are examples of grid modernization objectives. And so we're tying individual sort of more resource specific drivers to these objectives. And then each of those drivers maps to an evaluation category. So in least cost best fit, we have core investments. We have investments that support minimum reliability standards. And we have investments that are needed for policy-driven DER integration. In the best benefit cost analysis category, we have investments that are needed to support time varying rates. So this would include things like metering infrastructure, investments that are needed to support utility programs, and investments that are needed to support DER and non-wires procurement. And in the self-supporting category, we have customer-driven DER integration. So this could be, for instance, investments that are triggered as part of the interconnection process, and it could and customer-driven reliability. So again, this could be things like undergrounding, wires undergrounding. Next slide, please. But there's also sort of a less detailed way of going about thinking about investment categorization. So for instance, we could just take our pool of potential grid modernization investments, separate into core investments and application investments, and then separate application investments into utility investments and self-supporting investments. Core would be subject to a least cost best fit standard. Utility investments would be subject to benefit cost analysis, and self-supporting investments would be cost effective by assumption. Next slide, please. Before we get too much further, I wanted to come back and give a quick reminder of what core means in this context, and this builds off Paul's presentation from yesterday. So core will include things like the physical grid infrastructure, a lot of the sensing and measurement capabilities, at least some of the data analytics capabilities, some of the most of the management system capabilities like ADMS and OMS. It'll include a lot of the communications capabilities, and then the applications will sit on top of these core components. So the applications could include things like meters, volt bar management systems, and some of the more specific software systems to support distribution markets. The boundaries between core and application are going to be different by jurisdiction, but this just provides an illustration of the split between core and application. Next slide, please. So decision trees are a useful way to go about categorizing investments. This is an example from Hawaii. So their decision tree started off with a question of, will an investment, a particular grid modernization investment, be self-supporting? If not, will it help to meet standards and safety compliance? If not, will it help to meet policy compliance? Help to provide policy compliance? If not, will it provide net benefits? And if not, then the idea was that that's not a good time to make the investment. So this is just one example, and this isn't necessarily I'm not necessarily advocating this particular approach, and there's lots of different ways to do it, but more generally, decision trees can be a useful way to think about categorizing investment. Next slide, please. So I wanted to change gears a little bit and talk about risk management. So this isn't a specific step in the evaluation framework, but this is developing a way to sort of think about risk-based prioritization of investments is something that we were asked to do as part of the chapter. And this is something that sort of pervades the economic evaluation process. It's a little bit of an oversimplification, but I think it's useful to kind of consolidate a lot of the grid modernization investment risks into this sort of question about pace and too fast versus too slow. And it's important to realize that different stakeholders have different perspectives on this risk. So, for instance, utilities may want to go fast, but they also want to make sure that regulators are going to allow them cost recovery. DER providers and customers may want to go fast as well, but they don't want to overpay. They don't necessarily want to be first movers. Customers may want reliability, resilience, more reliability, resilience, and clean energy, but they don't want bill shocks. And regulators may want modern grids, but they worry about the rate impacts and potential technology obsolescence. Next slide, please. And so the question is, how do we manage the risk trade-offs across these different stakeholders? In the chapter, in the guidebook we identified a number of tools that utilities and regulators can use to do this risk-based investment prioritization. The first is long-term strategic planning, and the idea here is, if we can lay out what the risks are in a planning process, then we'll have a much better chance of being able to manage them. And one of the tools that utilities have historically used to integrate risk into long-term strategic planning is investment scoring. Another approach that's a useful analog from the transmission system is least regrets planning. And the idea with least regrets planning is that you develop a number of scenarios that lay out what your investments are and what potential uncertainties are, and then you look to see what investments are common across different scenarios. Another tool for managing risk is spending limits, and the idea with spending limits is that rather than concentrating spending on grid modernization up front, that we smooth it out over time. Another tool is pilots, and this is something that Lisa talked about. Pilots, for whatever reason, have not been a central part of grid modernization plans, but pilots are a really useful way to understand what the operational needs and organizational challenges required, or organizational changes required by different technologies will be. And then the fourth tool is ex post performance assessment. And the key part of ex post performance assessment, assessing investments after we've made them, is this learning and adaptation process. We're going to make we're going to make mistakes in grid modernization. The question is how we go about learning from these and adapting sort of our long-term plans from them. There's a useful, more comprehensive way of thinking about a lot of this in volume 3 of the Modern Distribution Grid. It's captured in this walk, jog, run approach. And the idea with walk, jog, run is that rather than trying to sprint out of the gate, that we kind of take a relatively slow approach and scale up over time as we build both experience, expertise, but also sort of the functionality in our system. Next slide, please. The last area that I wanted to talk about as part of this framework is evaluating performance. So this has become a relatively hot topic in a lot of jurisdictions. And there's no one single right way to do performance metrics, but it's important that performance metrics are set in advance and that they're linked to long-term and short-term objectives, so we can see from our performance metrics, are we headed in the right direction? Performance metrics can cover both deployment in operation, so they can cover both, did the utility install the number of widgets that it said it was going to install, but also, how did those widgets perform? And performance metrics are particularly important if we're using a least cost best fit framework for our core investments. And integrating sort of the performance metric setting process into planning is really important in this context. So, for instance, we're going to end up with a question as we sort of do this of how do we evaluate performance in things like advanced distribution management systems. If we, as we're thinking through the process of do we need this, and what is it going to give us? We can kind of take that what is it going to give us question, use that to develop performance metrics, and that'll help to sort of set both expectations and sort of more quantifiable metrics for core investments. And then lastly, again, to just harp on this, building this learning and adaptation process into the evaluation and into the evaluation framework is really important. And as a way to, the most convenient way to do it is to time it with planning and investment cycles, just as a way to reduce some of the sort of friction in developing the kind of knowledge base that goes along with this. Next slide, please. So their performance metrics are going to vary across jurisdictions just based on different objectives and priorities, but here's kind of a laundry list of potential performance metrics. So they could include deployment, customer satisfaction, reliability, resilience, safety, economic efficiency, network and data access. This is kind of a new and interesting area. Retail competition and program or rate participation. So for instance, this could be something like the number of customers that are participating in an EV rate. In some jurisdictions, commissions are going to want to explicitly link these performance metrics to utility incentives. In other jurisdictions, they may not. Next slide, please. So I wanted to give a quick summary to wrap up. First is that economic evaluation of grid modernization is complex and challenging. So if you're finding that this seems to be a really complicated problem, you're not alone. The second is clear objectives, robust and coordinated planning, and targeted evaluation investments can help to address a lot of these challenges. Targeted evaluation can be organized around different evaluation methods. So we identified 3: least cost best fit for joint and interdependent benefits, and compliance with reliability and safety standards and policy mandates. Benefit cost analysis, where we're expecting investments to produce net customer benefits, and self-supporting, and no sort of evaluation needed in cases of customer choice. There's a lot of different tools that utilities already have to manage risk. These include long-term planning, spending limits, pilots, and ex-post performance assessment, prioritizing learning and adaptation, and then lastly, the performance metrics are critical. Next slide, please. So I thought I had originally planned as an incentive to all of you who stayed on to the very end to put this to music, but I realized that might not be much of a reward if I didn't practice enough. So I'll just walk through these. So as part of the process of developing the grid modernization guidebook, and as part of the process of putting together these slides, we were pushed to come up with questions regulators can ask. And I think this is a fantastic way of sort of distilling takeaways from a lot of this work, and as a way to kind of build conversation among regulators, stakeholders, and utilities. So I'm just going to walk through these really quickly without accompanying music, but you can kind of think about the music in the background. First question that the regulators can be asking is, what are the objectives and priorities of grid modernization? What is it that we want to do? The second question is, what objectives are supported by individual grid modernizations? For instance, what is an ADMS system going to give us? Third is how should we be coordinating the different planning processes that are affected by grid modernization? Should we have a dedicated grid modernization proceeding, or should this be part of, for instance, a general rate case? Fourth, what are the drivers of different investments and how should they be evaluated? For instance, how much are we going to put in? How much of our investments are we going to put in core, and how much of our investments are we going to put in more of a traditional benefit cost category? Fifth, what are reasonable levels of spending, and what are the rate impacts for different grid modernization investments? How much are we willing to spend over what time period? Sixth, what are the performance metrics? What performance metrics should be used to evaluate investments? And likewise, how should these be integrated into utility incentive frameworks? And then lastly, how should we go about incorporating risk management into investment prioritization and decision making? What are the tools that utilities should be using to incorporate risk management? Next slide, please. With that, I think we're going to go to polls, but first, thank you for your time and for staying to the very end. And then after the polls, I think we'll take questions, and if you have insights that you wanted to share, that would be great as well. So the first question in the poll is, in addition to reliability and safety, what other objectives should be the highest priority for grid modernization? Please select one. Okay, great. So that's very interesting. It's not what I expected. So the winner was optimize use of gross grid assets and minimize total system costs. But a close second was resilience to natural disasters. It's very interesting. Next poll question. I think we had 4, but maybe we can limit it to 2 and then go to questions. How should the next poll question is, how should most utility grid modernization investments be evaluated? Just based on sort of what I just presented. Should most investments be subject to a least cost best fit standard using competitive solicitations, or should they be based on more traditional benefit cost analysis? Interesting. So most people felt that it should be based on traditional benefit cost analysis. So maybe rather than going through additional poll questions, maybe we can open it up to questions.
Thanks, Chris. That was a great presentation. I don't see any questions from the audience. I think, though, I'm going to use that last poll question as a transition. I was not at all surprised by the responses to the 2 poll questions. There's, of course, among public utility commissions, state consumer utility representatives, a real interest in minimizing total system costs, trying to do things at least cost. Can you provide any additional guidance in terms of, we're so used to this construct of least cost, and the point I think in part is like for core investments, let's say for resilience, or to meet a standard, you sort of have to make the investment. You've already chosen to make the investment. It's either a requirement or it's a state policy objective that the utility is meeting. And then the goal there is how do you make that investment in the most cost-effective way, being mindful of risk. I don't know if you could say anything more that would sort of it's an analogous process that you've seen in another state to sort of make a little bit of, understand the distinction that Department of Energy is trying to make with respect to these standards, investments because of standards or other requirements.
Sure. So I think maybe the best analogy is to think about the ways in which utilities have traditionally invested in the distribution system. So we haven't applied sort of a value of lost load based cost effectiveness metric for traditional distribution investments. In some ways, what we're doing is we're setting a safety and reliability standard, and that utilities are investing to meet that standard on a least cost basis through at the end of the day, this comes back to the general rate case. But I guess the distinction that's really important to make is between something like a utility investment in or utility procurement of distributed energy resources, in which case what we want to know is what does the utility investment in these resources, is the utility investment in these resources lower cost than some alternative relative to, we want to have this functionality in our future distribution system. How do we go about doing it? Which is, I think, more of what we're sort of Lisa is going with the standards compliance. Resiliency is a really interesting category in the sense that my guess will be that a lot of the requirements for resiliency investments are going to come from state legislatures, and this is something that Joe talked about yesterday. In which case, utilities are going to have to go through a planning process of trying to figure out, what's the best way to meet this standard at lowest cost. That falls more into more of the least cost best fit framework than more of a traditional benefit cost analysis.
Great, thanks very much, Fritz.